Hello and welcome here at BASF booth of K-Fair 2019. This is the second live talk of today. I'd like to welcome everyone, especially our guests. We're going to discuss the topic new ecosystem to change the digital manufacturing industry. And with me here discussing this topic is Philipp Jung from HP and François Minet from 3D Printing Solutions. So thank you for being here. And first question to François. What are the current challenges in 3D printing?
So 3D printing is an industry which is growing today at 25% per year, since many years actually. But when you look at it, it's a 6 to 8 billion industry, which compared to the total manufacturing industry is quite a small industry. It's less than 0.1%. So at BASF, we're aiming and we are working at growing this industry so that it becomes a mass industry.
And how far are we from that, you would say, to have this on an industrial level scale?
Well, today there are several challenges we are tackling for this. So there are three main levers that we are tackling. One is the consistency and the reliability of parts. Then cost of part also. And then the product offering. So if we look, I will go through these three if you allow me. So the consistency and reliability of parts. Of course, today you already have 3D printed parts which are on cars or on airplanes. But in general, the whole industry is not there to have the reliability and consistency of injection molding, which is the subject of this fair. So this is really one thing where we need to work together with the machine manufacturers and ourselves material manufacturers.
And this is where HP comes in.
Absolutely. So HP actually entered the 3D printing market about 3 years ago with the goal of changing how the world designs and manufactures. And HP has a benefit on drawing on over 3 decades of research and multi-billion-dollar investment in printing technology. So we're heavily leveraging those investments from the 2D printing world into the 3D printing world. So we feel we are very ready to address and tackle some of the challenges that François called out. So if you look, for example, at reliability and consistency, we introduced earlier this year the 5200 machine, which really brings together as a solution software, systems, data intelligence, and services to bring manufacturing to a whole different level of accuracy, repeatability. So we can achieve actually a CPK of 1.3 for those who are familiar with those accuracy measurements. So that's how we think about reliability, consistency. If you think about cost per parts, that's also driven down. I mean, the whole idea behind multi-jet fusion 3D printing technology is productivity, is be ready to change how we manufacture and therefore drives the cost per parts down. And the last item that François mentioned, sort of the offering, the lever around that. So we not only introduced the industrial system that I just mentioned, we introduced a new prototyping system that includes color capabilities, and we expanded our software capabilities, what we can do, and bring machine learning into the discussion here and into the offering.
And in achieving this, for you as HP, what's the importance of collaborating with the material deliverers such as BASF in this?
It's actually very critical. In order to be successful in the additive manufacturing industry, and really requires an ecosystem of partners that goes across. It includes go-to-market, includes automation, and very, very important, obviously, materials provider like BASF. And so we've been working actually very closely with BASF on not only developing new materials, but also getting BASF feedback on tuning the machine, really getting to the performance that we ultimately talked about earlier and need to achieve to change how the world designs and manufactures enabled through 3D printing. But to be honest with you, we also collaborate with our customers to, again, really think about what's possible, what can be done with additive manufacturing to open up the material space. And we're not really stopping there, right? If you think about it, it's a new TPU material. What we opened up, it's like parts like the one you see here, which is a windmill maintenance parts that we developed together with BASF, flexible part. And there are more products coming. So TPU will be officially announced and launched at Formnext, although you can play around with it. And there's more to come in 2020 in terms of materials. All ultimately with the goal of opening up the application space.
Francois, from BASF perspective, what were the challenges in supplying that kind of material?
Well, developing product for 3D printing is per se a challenge. In this case, the raw material is a powder, a very fine powder, 50 micron, and it has to be manufactured with a very tiny and strict specification. But to achieve the level of consistency and reliability which is needed on HP machines, we have also to put in place a much more consistent manufacturing process, special QC, to achieve these goals.
Okay, so quite a bit of
a challenge
and work that needs to be done. Okay, but looking at things we see here, it was a very fruitful collaboration already. So I guess you found a way to overcome those hurdles.
Yeah, so I mean, at the moment we're still in the beta phase. So we have already engaged some customers to develop application. I just showed the one that Philippe just mentioned. That's it's a part used by Vestas for the manufacturing process. And basically this is a jigs and fixtures. So meaning the customer will use this part to clamp around some beams which are used in the manufacturing of the windmill blade. And basically you clamp it, and once you clamp it, it's protected for manipulating it. So the interest, why 3D printing? Because if you had to injection mold this, you would need to do a mold each type, and there's a lot of these clamps. So it would take a lot of time, a lot of cost. And in this case, you can just take the CAD file, and the next day you have the part. And why TPU? Because in this case, when you clamp the part, as you can see, it's soft, and it will not scratch the part. And of course, you want that if it falls down, it doesn't break with the part, and so it's protecting the part. So that's the interest of TPU.
And what's special about the helmet?
Well, look at the helmet here. Is a few things, and you're wondering why do you do 3D printing of a helmet? And it's really the key thing. You can do lattice structures. So this you see here the lattice structure, which is only possible to manufacture through 3D printing. Why lattice structures? Lattice structures actually allow you to replace foam because it's ultimately energy absorption. And you see here a helmet, and you can imagine the helmet for all kinds of applications. So you can use it for football, you can use it for skiing, different sports. You can even use it in the medical space. And now the interesting part is you can not only customize it to the specific sport or application like medical, but you can also customize it to the individual and to the very specific situation. And you can design it, essentially design a lot size of one and enable essentially a lattice structure here, which again makes it very, very unique on 3D printing and what can be done with TPU from an energy absorption perspective.
Yeah. So the example you were mentioning with the baseball players, for example, is actually really cool, right? Because you could go over there, scan their heads, and then have customized perfect fit helmets for all of them.
Exactly, and specifically for what sport somebody plays and what specific requirements are for energy absorptions exist. You're absolutely right about that. Yeah.
So really, really a cool application.
Yep. Let me show you actually one more application here of interest. I get always excited about everything you can do with TPU. But here you see something called it's actually for our own 2D printers that HP has. It's a code wheel cover, which has a modular design. And you're wondering, why do you use TPU? Why 3D print? One, it allows a modular design, so you can actually fit it into the printer, into the 2D printer. And then you have a flexible part because that part needs to be maintained every so often. So you have a lot of assembly, disassembly. And though with TPU and the flexibility of TPU, it withstands the frequent assembly, disassembly, the impact that comes. and at the same time, it covers sensitive parts like the encoder, for example. Again, an example where we said, oh, let's see what we can do with our own products enabled through 3D printing and TPU.
So this is actually an example of a printer supplying another printer with parts.
Exactly. So we can almost say the printer prints itself at the end.
Yeah. It's getting more and more crazy, but very interesting.
Yeah.
So with this, actually, I'd like to thank both of you. Thank you, Philip. Thank you, Francois, for being here, for talking about this, and many more exciting applications and things to come.
Yeah, no, thank you. Thank you for having us here. So it was very exciting to talk about it, and especially the partnership with BASF, what that enables for us, and working together.
Thank you.
Great, thank you.